In 2015, a series of droughts started to dry up this dam, the source of almost half of the water available to Cape Town, South Africa. In this satellite time-lapse, you can literally see the stored water decrease month by month. In 2018, the city was approaching day zero.
Day zero.
Day zero.
Day zero.
Day zero is fast approaching.
Shorthand for the day the taps run dry, and people would have to queue to get their water rations. Cape Town was the first major city to risk running out of water. But it's not going to be the last. Jakarta, London, Beijing, Tokyo could all face their own day zero in the coming decades.
Most parts of the world, or at least for 1 month a year, are experiencing some water stress or water scarcity.
The gap between demand and supply of water is narrowing down.
But how can that be? Our planet is awash with water. More than 1 billion trillion liters to be precise. The problem is that 97% of the Earth's water is salty, and most of the fresh water is frozen in ice caps. Less than 1% of the Earth's water is drinkable. That makes one solution especially promising.
Desalination.
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 Desalination seems a pretty straightforward solution. You take that undrinkable salt water, you remove the salt, and you have an unlimited supply of fresh water. So, why are we not building more desalination plants? Desalination is a natural process that's been known for millennia. As already Aristotle noted, the sun dissolves ocean water into vapor, which then condenses again and falls back as rain. His compatriots took note. Greek sailors boiled seawater for long trips. Romans used clay filters to trap salt. These are still the two basic principles used today. Thermal desalination uses heat. Salt's boiling point is a lot higher than water. So if you boil salt water, only fresh water will evaporate, leaving all the salt behind. Membrane desalination uses pressure. Salt water, here colored in red for clarity, is pressed through a membrane that is only partially permeable. Fresh water can pass through, here colored in blue, but the salt is trapped on the other side. The technology didn't improve much until the 19th century, when industrialization and population growth encouraged more research.
Population growth is the main driver for increase in water scarcity.
Manzoor Kadir is an environmental scientist with over 30 years' experience in water management.
Say, for instance, Middle East and North Africa region. That region has a population of about 5% of the world population, but just has 1% of the global water resources.
And soon another factor could make desalination even more crucial: global warming. As the climate warms, more water will evaporate. And as Aristotle noticed, more vapor equals more clouds equals more rain. But that rain won't fall evenly. This map shows how precipitation will change as the climate warms. Regions in purple will get more rain, those in orange less. Now compare it with this other map. The red dots here show areas that already today don't get enough water. Dry areas like California and the Middle East will see even less rainfall. Other countries like India will have more rain in the monsoon season, but less in the dry season when people need it most. This will make desalination even more popular.
And this really has started to explode, I'd say, since the late 80s and 90s, but especially in the last 20 years, you've seen a big acceleration.
Edward Jones is a PhD researcher who has put together a state-of-the-art outlook on the status of desalination.
And nowadays, we have around 16,000 desalination plants. which are producing more or less 100 million meters cubed of water per day.
But take a closer look at this map.
If you look at how much desalinated water we produce on this globe, currently 71% is produced in high-income countries.
That's because desalination is very costly. Boiling billions of liters of water takes a lot of energy.
In the Middle East, the availability of oil and especially fossil fuels makes the thermal processes cheaper. But for other types, it could be, I think, 25 or 30 times more expensive.
But that energy doesn't have to come from fossil fuels. But there's another problem. What do you do with this water?
So we forced all of this salt out of the water to produce our fresh water, but now this salt is still contained within our substance, but it's just in a smaller volume, so it's more salty.
This water is called brine.
At the global level, we produce more brine than we produce desalinated water.
You've got your pipe that's coming out of the desal plant. You're discharging hypersaline water here. And as it flows out, it will sink because it's more dense. The salinity and the temperature can also deplete the oxygen available. And this is what's causing actually the organisms more damage. Just a lack of oxygen, they're basically suffocating.
Brine can also contain chemicals harmful to sea life.
There needs to be a better plan for the industry of dealing with this brine. We're producing more waste with no plan.
But what if this waste could become a resource? Tomato, seaweed, and certain fish can tolerate high salinity. Borealites uses brine to cultivate them in tubs like this.
There's also the opportunity for salt recovery and for metal recovery.
At the moment, the technologies are available for brine management, but those are on a very small scale. The challenge is that how we can transform those small-scale technologies into a large-scale operation.
Desalination is not a magic formula. The process must become more efficient before low-income countries can afford it. Plants must convert from fossil fuels to renewable energies to limit emissions. And the whole industry needs to come up with a plan to deal with this brine. But plants like this are already a lifeline for many communities.
It's very important to realize that desalination is here to stay. We really need to work towards solving the challenges of desalination.
This is a gradual process. This will not again happen overnight. But I could see that there is a push. At the same time, there is a willingness also to harness the potential of desalinated water.
Today, Cape Town is doing a lot better and the dam is almost full. The city was rushing to build desalination plants to avoid day zero. But the solution was not desalination or any other technology.
No one should be showering more than twice a week.
Turn the tap off.
Flush with only when you really need to flush.
We've made a massive effort in trying to use as little as possible.
You have to save water as if your life depends on it.
Citizens became water-wise. They radically changed their water use.
We use it consciously and mindfully.
We are trying our best to save water.
And they valued water for the essential and irreplaceable substance that it is.
Fun fact, the amount of desalinated water that we produce every year is comparable to more or less half of the water that falls over the Niagara Falls every year. That's it from us. As you can guess from this quick time lapse, these videos take a lot of time, so if you liked it, please give it some love. Share, subscribe, press the like button, and stay tuned. We have more videos like these coming out every Friday.